Okay, it says it's going live, so hopefully this is it. Can you guys hear me out there? Maybe it doesn't start for another 2 minutes. All right, anyway, today what we're going to do is talk about the Graviflyer, and hopefully you guys see this okay and my mic's all right. But anyway, a couple questions right off the bat. We'll start with how long do I think until it levitates? Well, it kind of is what it is, guys. I mean, this is a research project, so we're getting through it, but it's not probably going to be in the next month or so, if that's what you're thinking. It's going to take time. Let's see. Another one. Is it working? No, obviously it's not working just yet. Let's see. One thing I'll say about this thing, it's more of a static electricity thing on a lot of it, and it's fields interacting. So not everything's going to be exactly what you think it is as this thing goes. So anyway, let's just I can't tell if this thing's live or not. So anyway, it actually what I'm dealing with right now is the fields on this thing. I'm trying to get rid of the field on the top disk, and I'm trying to make the bottom disk actually play with the center plate a little better. So thank you for that. Let me know. Okay, cool. So this device right here, it's not exactly like I was trying to say, the fields. What I was getting was, as you put the Tesla coil to the center on the two plates, and I'll show you, here's the Graviflyer here, obviously. So on this right here and this right here, this plate, I'm putting the Tesla coil to that. Now, normally you wouldn't do that, and it's supposed to be the other way around, but I couldn't get the field to generate on the outside. So as I put all the voltage in there from the Tesla coil to the outside, I couldn't get my little light bulb to light up as much as I wanted it to. It did here and there and in spots, but it wasn't giving me an overall field around the entire craft. So it was a problem. So what I did was I decided, well, let's invert it. So let's go with the static on the outside, and let's go with the Tesla coil on the inside. Well, being that it's a static field, it's going to interact with the air molecules around it, and you're going to excite a lot of things around it. So even if you get next to it, it's going to be bad. So what happened was, is the Tesla coil, being that it pushes out energy as a normal thing for it, it forced that field out everywhere. And as you can see, the metal box behind me, that's usually when I put my controllers and stuff. I fried two controllers right away. This thing was on the ground, and the controllers fried in that box. They all electrified. It basically made that into a giant antenna, and it was just blasting out. This thing was blasting out here, and I almost lost my TV, my computer, and everything because of it. So what I would say is, I don't know that I have enough strength in my field on the outside for my Tesla coil to be on the outside yet. And I'm running at 33 volts. So it's not heavily volted, but it's enough to create some kind of a field, just not enough. So it's not creating the bubbles like I want it. So in this upper disc right here, I want a bubble to form around it, around that static volts, because I want it to compress. So you see the energy, it flies out when you do it opposite, but I want to do it back the regular way and get it to compress inside. I need it to I don't know how I want to say this, but if that bubble, it doesn't have force on it, then it's no good. Too much static electricity on the outside is bad as well. It's not going to give you everything you want. It'll light up everything and it'll ruin a lot of electronics, but it's not getting to the point where it holds it in. And that's really what I need, is once I can get those two fields set, and I can get this ultrasound part right here on the top. Here we go. On this top part right here, the ultrasound's right up here. So if I can get that to disperse this field right here when I want it to, I can get it to fly. So I think that's where I'm at in this. So, I mean, hopefully you guys understand that it's kind of just a different animal altogether. I've taken static lifters and that lift on a static field, and I can lift those all day. I can put pressure on stuff all day, and I can get those things to exert a lot of force. And I'm not talking just a little. If I wanted to make a swing out of it and make it swing like a pendulum, I can do it all day long. Or if I wanted to do T.T. Brown's experiment where you had the two out here and spun them, I don't think I'd have a problem because I can exert a ton of force with static electricity. It's the fields that I'm having a problem with. I can get enough static in there. I don't know that I'm getting enough of my Tesla coil on it. And that's what really bothers me. So the circuit I'm working with, it only gives me 40 volts before anything after that, it gets a little bad. But the 40 volts should do a lot for that Tesla coil. My concern is if I get it any higher, then, you might start seeing spark shoot out of this, which is not what I want. I just want a field to hold it in. So hopefully you guys saw the intro video and you saw the tuning that I was doing. So when you see both of them going on, what you're looking for is, I want that bottom one. It's only going to go about 350 RPM or less. So what you're going to get out of that is a pulse rate. The pulse rate actually goes to your center disc as well. And no matter how you set it up, you can touch your little light on here and you're going to get the same pulse that you do as your bottom disc. They're exactly the same. So you can tell that the eddy current has gone into the center plate and got it to a point where it's interacting with the center plate. So you can see that right away when you put your light bulb up to it and check it and you have the field strength on here. You can see that pulse rate. Now, the funny thing is when you look at Alexei's, when he has this thing up, right, and you see the center right here, you'll see as this bottom disc wobbles, so does his whole craft. It'll just do like a little floating like that and wobble back and forth. And that's the bottom magnets on there interacting with it. So let's see. What are your thoughts on using piezo transducers? Well, I use the piezoelectric part in the top. So the little round disc, I use those. That's what's going in the very top here on this. The actual transducer part, I don't use at all. I use it in testing to check out the vibration frequencies for the center disc. What I do is I hook it to a separate plate, and then I'll tie it into the part right here where you have the hole in it. I'll just tie it in right there. And what it does is it gives me a frequency. So now I have a baseline. And now I can distinguish what else is coming into it, because then I'll have a frequency and what's coming in versus what was already there. So you'll see the eddy current hit, and you'll see a little spike going on that. You'll see the top disc here hit, and you'll see a little spike in that. It's kind of tricky. I use a speaker wire to hook to this to get the frequency, because the outside insulation acts as a resistor, so I don't blow up my oscilloscope. So some of the numbers may not be 100% on, but they're getting there. Let's see. Let's see. Is Alexei out there? Why can doing? Okay, Alexei's out there. From what I understand from Charlie C, and also, I don't want to say this. They found him. They can't get him to get back to him right now. And as soon as they do, they can run some more stuff. They actually have video of this guy testing this thing in front of them. And from what I understand, it's an amazing video, and it should put everything to rest on whether it's real or not. So I'm going to say it's 100% real based on them. Jared goes in there and talks about it, and he has more details on this than I ever would. But from what I understand, it's good, and I can't wait to get my hands on the video as soon as Alexei says we're okay to publish it. I'll put it out there. Yeah, the last video shook me up a bit. Yeah, you know why? Because I felt the voltage inside me. It was, and I don't mean that like it started inside me. that thing was like a wave that hit me. Usually you get some, how do I say this? Some off gases here for when you run the high voltage. And it was like hitting it at 100 times to what I would normally feel when standing next to high voltage. Massively, massively big headache for the next 2 days. So yeah, it definitely got to me. Kind of one of those moments when you get shocked from the wall and you go, well, maybe I should just sit outside for a little while. That's exactly what I felt. So yeah, it was pretty bad. No, you know what? Am I worried about big energy coming after? Yeah, a little bit, to be honest with you. Absolutely, I'd do it again, though. I know that sounds nuts, but it's just the way I work, man. I have no fear of doing it again, but in the same thing, I know exactly what's coming at me, and I know exactly how bad it's going to be. Now, whether it's left on for longer or not, again, we were talking 45 seconds. This thing is lighting this whole room up. So it's going to be, I'm going to be stuck in an energy zone. So, cross your fingers. Let's see if it works out. So, yeah, just a little bit. Let's see. Well, I am getting, because of the tune that I put into it, I am getting resonance. So I don't have a worry about that. I'm definitely hitting the resonance in this thing. And you can tell based on that intro video where I tuned it just like his, where the bottom motor was running about the same speed. And what happens is you put voltage in the top, it'll balance it or unbalance. So I'll know exactly where he's at on the top without knowing the exact speed that he's on, because I can create that same imbalance in balance mode. So I know exactly where it is. So the actual resonance in this thing, you can just run the top two and you can get a number out of this on your oscilloscope. And I have, and it's definitely putting it out. Okay. Be safe. Yeah, I'll try. Sometimes not so much for me. I end up shocking myself a lot. Let's see. How many volts do you think we'll run into? Run it on? To be honest with you, this thing is relatively low voltage. It's when you cross voltages is when you have the amplification of something. When the Tesla coil crosses that static electricity is when you're going to get an amplification. That's what I was getting. It's pushing fields. If you notice in my light test, when I put it on there, you barely get anything. And then as soon as I hit them both on, it lights up right away. And there was no motor, so no push to go out. It wasn't pushing it out yet, but you can see how bright it got. It would basically be about sticking 60, 70 volts into my Tesla coil is what I would get on how much voltage was going through that when they're connected. So it definitely increased everything. So let's see. Parts come tomorrow. Yes. For you. Yes. BT7274. Good job, man. I can't wait to see yours. It's a spirit. Yeah. Helmet. Alexi's helmet. Oh my God. Maybe. I don't have an old motorcycle helmet or something or a welding helmet anymore. I got rid of it. So I don't know about all that. Maybe I try a tinfoil hat, but I know I'm going to get shocked. So maybe be funny for a couple of people, but not so humorous for me. As low as 200 RPM, it's hard because this bottom part right here, these are fan motors, so they just suck. Let's just get that out of the way. They just overall suck. So let's see if I can turn it and you can get a look at this. This right here is the little piece right here of metal that's going up. You can kind of see it touching that disc right there. What happens is when it touches it, it slows down the bottom. So whatever speed you get to, it's going to slow it down. And I don't have anything to put it in slowly where it can touch later on after the motor's built up speed. So it has to break the speed of everything. So I can't connect it, where it's making those sounds that, and doing all that. I can't connect it that way. It just won't work. So I have to do it at the speed that it goes. If it gets down to 200, it goes down to a stall rate. About 350 is where it stays, and it'll continue running. The upper motor, it doesn't care. It has no pressure on it. That little piece of metal that goes into it, not so much of a problem on there, but the bottom is absolutely, yeah, it has to be done just right. So, Daniel Foster, I wish I could afford one of those. Yeah, well, it's not too bad, considering, you got the STLs out there I put out there. The fan motors are pretty cheap. The metal gets pricey. If you can find some of that at a relatively cheap price, the rest of it's not so bad. I mean, you can get away with building just the actual part right here for a couple $100, but it's the added things that you get into it. If you have an old TV, you can save money on a flyback. If you know how to build, a way to drive that, even a simple transistor would drive it. You could do that, but yeah, it gets up there. I think I'm at like $5, $6, $7,000 on just equipment, parts, things like that, just in research and development to figure out things. This is the fourth one I've built. Some of them I fried them. Oh my God. I put my Tesla coil into one of these things, and I had 400 volts of DC power that I put into this thing that I transferred over to AC and ran it in my Tesla coil to this and fried the living daylights out of every motor and everything on it. It didn't really make a great glow. It just made a boom, and you just saw things popping and frying. So yeah, the more power is definitely not the answer here. So 3D printer isn't big enough for the template. Well, if you run just the top one right here and the bottom one, they'll fit on an Ender 3. So 255 by 255, I think, or something close to that. Those will run on an Ender 3. You can get those. You may not be able to get the template to do the rest of the stuff, but if you just take your time and cut it out, and you'll be okay on that. The biggest thing is to get these right here. Those are gold, man. You get it all lined up correctly. Do I see a point where I can do a Raspberry Pi? I was looking into our Arduino. Once I have the voltages set, not a problem. Once it flies, not a problem. It wouldn't take more than a day or so to get it to get into a test mode, and then to get it to be able to be replicated by everybody. You just got to make sure all your proper sizes are correct on everything, that it's built the same way, and be just fine on that. But it shouldn't be that bad at all. Yeah, I like plasma too, man. Kind of an addict to it. Okay. Yeah, I plan on doing outside testing probably here in the next week or so. Hopefully that'll go really well. I got new motors coming in. I stockpiled a couple because I keep blowing them out. So, and what the problem is these Chinsey wires right here. There's no shielding over them. So I'm just going to go get me a cable with some shielding on it and put it over to them. They keep touching any part of the metal you touch with the wires, fry the motors right away. And it's probably the windings are fine. It's just that little, I don't know, little electrical thing in there, the circuit, it fries immediately without question. It doesn't do it as long as they're not touching it. But the problem is I wanted to use the thinner wire with the bad shielding because Alexi's wires are like that. So if there was a way that some of the voltages were interfering with the motors, I wanted to preserve that, and I didn't want to change that out. So hopefully it works out. I can just do what he did, put a little bit of shielding on it, and I might be okay there. So, oh man, so people got some UFOs over. That'd be cool. Honestly, I hate to tell you this, but if a UFO comes for me, I'm going. Okay, I'm riding everywhere. Don't ever try to stop me. I'm going. If they say you'll be back in a couple of years, yeah, let's go. Not even a question. I'm on it. So, yeah, no problem there. I'd love to speak to some aliens. That'd be just righteous, man. I'd love that. Let's see. Be a good way to compare notes. My email, oldmannathanbunten@gmail.com. Usually I leave it for people. I leave it for people if you ask. and you can shoot me an email anytime. We can compare notes, compare videos, things like that. If you are interested in doing that, like I said, it's oldmannathanbunten at at gmail.com, and I'll try to leave a link in the description for you guys so you guys can get it. So anyway, let's see some other things on here. Old man made a toaster. Yeah, maybe. You know, I'm the toast. That's what it is, to be honest with you. It's the way it feels like it sometimes. Okay. Recently found your channel and watched all your research, and I wanted to ask if there was any idea of incorporating mercury into the vortex. Not unless I'm in a real lab. I won't do that in my garage. It get real nasty. The voltages I like to play with, it likes to pop things. So I can only imagine mercury splatter everywhere, and it probably would not help me at all. So nope, not unless I get into a real lab and have a confined environment. But then, hey, all bets are off. Let's go for it. You know what I mean? Balls to the wall, man. That's just the way I am. Let's do it. So I don't have any problems doing it as long as it's in a safe environment, because this isn't, and I got kids and I'm not doing that. So, but in a safe environment, absolutely. And by the way, I'm building a big box here. You can't see it behind me, but I'm actually trying to get a vacuum chamber up and running that's big. I need it big enough to run this in there. I need to see if there's anything coming off of it. You know, everybody wants to talk about, you know, hey, is it going to be an ion lifter, stuff like that? Well, it's too heavy for an ion lifter. Ions are coming off of it big time, but they're not in a direction that's useful. It comes off the side. It comes off here. There's no way to lift it. There's no way to get any kind of liftage on that whatsoever. They need to be contained in a field. And I'm hoping by putting it in a vacuum chamber that's big enough for this, I can run it and get some good tests on it and see exactly what it's doing. So, yeah, in a vacuum, that's the way to go. You got to test it. You know, like I said, with the static electricity stuff, I need to put some of those in there as well. You know, I wouldn't mind winning some money on that TT Brown thing, like the rest of you probably seen. What is it, like 50 grand or something? Yeah, you pass it over here, buddy, because as soon as that thing's built, I'm putting it in it, because I can do it in the air, no problem. You know, in there, you know, we'll see. If it works out, it'd be awesome. So let's see. Gallium. I've never worked with gallium, to be honest with you. I have to look into it. I'm kind of at a loss there for you. Faraday cage, absolutely. If I'm going to test it in my garage again, it's going in a Faraday cage. And not only that, you know, it might give me a chance to put in some sensors and actually get some data from it on that Faraday cage about how much voltage is pushing out. So I can, you know, just pop it in there. Hopefully it'll work through the Faraday cage. You know, maybe it'll work for 5 minutes and, you know, blow up on me, but at least it'd be 5 minutes of data that I could use. So that'd be good. Can I sorry, let me say this again. Can you create a field containment bubble using resonant frequencies? I don't think so. I don't think it's going to create the bubble on resonance. It's going to need a electrical component to the resonance to do it. I think in order to create the field, to be honest with you, I'd love it to be static field on the outside and Tesla coil on the inside. And I say that, and that's the way I set it up on this last test. The reason I really want that to be the answer, because I do think that's part of what blocks gravity, is that static field. It's a natural effect of the earth. So as long as you stick with things like that, you can get in like terms with the energy of the earth, and you can start to bypass the stuff that the earth does. And I don't think until you do that, you can. So I'm really hoping the static field's on the outside when testing's done, because I think it's going to be better off. But the resonance itself, what I think it does is it vibrates everything at a very fast pace. So if you think of gravity coming down in waves like this to your craft, right? And you got this thing and you got this wave that comes down. Well, you want to block it and shoot it off to the side here. You know, just get it to come over to the side. That's what you're looking for when you're creating that bubble. So if we excite the air, maybe we can get that to make a field that it goes over and out. And that resonance right there, it's going to create that vibration in the entire craft. All of it's going to have the same resonance frequency. It's all aluminum except for these. So even at that, it's still going to create it. So yeah, one cool thing I'll just tell you guys is I polarized this right here. You could say magnetics, you could say polarization. All I know is things stick to it now. So not now, right now, but when I have the voltage on it, boom, sticks right to it. If you see my experiment when I did the tinfoil and the high voltage coil, how it sucked down to the table, all that is polarizing fields coming together and holding it together. And I think that's what was going on here. I don't know if it's complete magnetism, but it's definitely polarization. And the high voltage coil, people may not understand this, but it's going to actually give off a magnetic frequency. Along with your voltage, you got magnetics in there. And what it's going to do is it's going to add some magnetics to this, and it's going to work with your bottom plate with those magnets. So as much as everything else is going, that's why it's like a little, I guess Alexi called it like a little lock. You got to have the right numbers on it to get the lock to open. Well, I think that's why he's saying that. So let's see. Is textured aluminum really that important? And I think the answer is yes. And it has to do with the harmonics of it. It's going into different harmonics because of the textured part. Now, the center disc, not so much. You're looking for resonance in there. But in the upper and bottom one, you're going to have some harmonic fields in there. And the harmonics are interacting with the actual high voltage field on the top and bottom. So, yeah, it is important to have it in there and not so much on the center disc. Let's see. Center plate, like different dielectric materials test. Yeah, I have tested some. I put it in there. I put it in foil. I put it in balsa wood. I've also gone around. Let's see what else. I used sheet metal. So probably real thin, just like this stuff. I've used that. I didn't have any brass to try, but everything kind of, it does the same thing, creates a field. The problem is this is top plate's aluminum, center plate's aluminum. If I'm going to hit a resonant frequency, all of the materials are out. It has to be the aluminum because I need that frequency to go into the plates as well. So, because once the center starts, these top and bottom plates start as well. So any other material that you want to put into this, you'd have to make the whole craft that way. So not really something that's working for me when I did it, but it makes great fields. Electrical fields stronger, magnetic fields stronger when they put the top plate as copper or bottom plate. Sure, it works out great. The problem is it's not giving me the resonance frequency that I want through all three plates. Let's see. I've tried negative voltage on the center plate. Let me tell you what it does. It creates a field right here. And it goes right to the center plate, and that's it. And negative to this does that. So if you're talking electrical speaking with the high voltage coil goes to here. If you're talking about, do I want to take the field to all negative? Absolutely, I'm trying it. Guys, I'm going to do it all positive, all negative. Anything that I can get to force against this earth to make this jump, I'm doing it. So please don't ever think I won't. Any kind of movement on this thing off the ground is a success. Whether it's a false success or not, it's going to be something. So it's better than what I'm getting now. So yes, I will try to take the fields and change them to all negative or all positive or mix in the 2 or 3, however I got to do it. So absolutely it's on the table. Let's see. So I believe the shape plays into the resonance. Need to be free, vibrate. Yeah, I believe that as well. It's how badly he constructed it before. If you could say that it was part of the charm of it. Yeah, I agree with that. So it helps it vibrate through the whole thing, and I definitely agree with that. Let's see. How does Tesla stop from being grounded? Well, I don't know that it is, to be honest with you. I don't know that the Tesla coil stops from being grounded. When this is on the ground, it's actually, you can interact with the field a little bit on the ground. You get a couple sparks here and there if you tip it to the side. There's not enough voltage to zap the living daylights out of you. And to be honest with you, I expected to get burned, and I didn't. So, um, yeah, I mean, Tesla coil is generally a capacitor to ground. So you would think if it's a capacitor to the ground and the ground can be interacted and used as the ground as your negative on your high voltage coil, you would think we can change this into a negative field and bounce it off the bottom, the ground, because it would create a big boom, just like that, and jump it. So maybe it's still in the future, maybe it's not. I'm not sure, but yeah, I get the same thing, and that's probably why it takes both fields to get that bulb to light up, is because it's grounding out the Tesla coil. But in the air, it's useless. I mean, this guy puts it on the ground and does it, so I'm doing it the same way. So, I mean, it is what it is at that point. So, let's see. Differences in the benchtop power supply versus car battery. I haven't used a car battery on this. And I think, when we come to that field that pushes things out, I honestly think it's pulling energy from somewhere else. And it could be pulling it from the wall where I have everything plugged in. And it's because the frequencies are so low on the bottom disc. And you get that frequency that comes in on the center plate with that. I think it's pulling energy from the wall more than what I think it is. And it's bypassing some of the circuitry and going in. So when I look at a car battery, I may get a lot more amperage than what I'm thinking I would normally get. It may end up spiking some stuff. So it's worth a try. I'll absolutely do it. I don't have a spare car battery on me now, but when I do, I'm definitely putting it in there. I'll just have to convert a couple circuits a little way, put a little more protection in them than what I have for the wall circuits, because you get lost in amperage and blow stuff up. 3D printed aluminum shape. Never heard of the 3D printed aluminum. You know what? I take that back. I have seen printers that print off metals, if that's what you're talking about. So I'm not sure that it would go good or bad. If it's conductive, I would love to do it and use it for this top piece right here. I'd love to do it to connect the top on this. So you see the metal right here, right? On all three of these. And then this is plastic. I'd love to get the metal to come over top and complete the field on the top. So if I can get 3D printed aluminum and it's conductive, I'll do it. I'm in. I don't mind buying another printer to do that. I got like 22 of them, man. They got Ender 3s behind me. I got, about 8 or 9 CR10s right here. I got some IDEX printers over here. So I don't mind, whatever we got to buy to get it done, man. That's what I'm into. So everything we could do is going to work out. Let's see. What is my background on high voltage? Well, let's just say it this way. I retired probably about 9 years ago now. And I basically picked up, like you guys would, just a flyback and a driver for it. And I built it and worked it, and it worked okay. And you'll see on my channel everywhere, I use high voltage to create plasma displays. I love to do it, and I love reverse engineering things. So I I went on Plasma Channel and reverse engineered his thruster on there, and he actually got a hold of me because he's filing a patent on it. Wanted to make sure I wasn't trying to file one. I just copied his. I thought it was awesome, and put the STLs on my Thingiverse account. So it's pretty cool. But to get on with where it goes from there, I just built it, guys. I'm not an engineer. I'm not a physicist. I'm not any of those things. I'm a garage guy. I try everything. probably why I try everything, because I don't know any better. But you know what? I'm getting answers out of it where people don't, usually get answers out of things. So why not? Let's just do it. But anyway, yeah, I built, DC flybacks from scratch. I built AC flybacks from scratch. I can build any kind of transformer from scratch if I wanted to. And it really changes your understanding of how these things are working. I keep telling people there's no AC in my Tesla coil, and they go, "Oh, you're crazy. Tesla coils are always AC." Well, it's a pulse wave DC, and I don't have any AC next to it at all, ever. So, except for that one time I blew up my Graviflyer, but that was different. This coil is all DC. That's why the actual field of the flyback and the field of the Tesla coil are interacting so well, is because you could basically use the same driver to drive both. You could put in the same energy to both. The only difference is the configuration of the Tesla coil versus the configuration of your flyback. That's it. It's just a pulsed DC. It's like I tell people, I could take a tuning fork and turn on a transformer if I wanted to, because it's just a pulsed energy that turns them on. It's a magnetic field that goes back and forth like this, and that's what's creating your energy in every one of these. So it all interacts really well together. So anyway, yeah, I mean, I guess you gotta have to know that when you're playing with all this stuff. So building everything from scratch really helps. So let's see. High K factor dielectric with TT Brown. Yeah. Well, you know what? Here's the crazy thing. If you saw my experiment, and if you watch my stuff on the Graviflyer, you've seen it. The actual, how do I say this? The little UFO thing in the center, the paper thing. You have that, and you have a big piece of aluminum at the top and a smaller one on the bottom. And it has to go that way, small to big. And you'll see this thing jump up, right? Well, if you look at it upside down, you turn it upside down, what happens? The force goes down towards the bigger disc. And prying it up is almost, you can't do it. Not a whole lot. I mean, you can, but it's a pain. You can't touch it. You got to take a ruler, plastic ruler, and pull it up. And the force on it is way more than you think it is. It's not quite two neodymium magnets trying to pull them apart, but two earth magnets is stronger than that. Not quite the neodymium, but it puts that much force onto it. So why I'm saying this is the center, actually, instead of a dielectric, the energy is in that little UFO shaped paper right there. The energy is right there. So it's storing it in there. So it becomes, because it's actually static field that's in there, it electrifies it and stores energy there. And that's where you're getting to get that force. So do I need a heavy dielectric? Not really. Not on this experiment anyway. Now, if I just wanted to build a straight capacitor, absolutely, a super high K value dielectric would be perfect. So, all right, let's see what we got here. How are your modules holding up? The DC ones, the bigger ones that I run on my second Graviflyer, not a problem. You'll see that in the big build video. Those ones, I never have a problem with high voltage. The high voltage is not affecting these ones as much either. It's these wires that keep getting hit on electrical things that blow up. Is really what it is. It slows them down over time, but it's not frying them outright. So it's working like Alexi said it would. And you could see when he runs his device how they're running and how fast they're running. So I know everybody talks about camera speeds and stuff like that. I'm just going to tell you they're a bit slower than what you think they are. And honestly, you're going to have to just put one in and check it out, because as soon as you do, you'll understand exactly what I'm saying. It won't even move if you have the brushes too tight on it. So let's see. High voltage doesn't mess up the bearings, not necessarily. I guess anything over time will mess up, but I've blown them up faster than than I've had time to run them in that. So no, I haven't run into any more problems with that. It's usually the windings that'll fry. You get too much voltage in something, and the windings will fry. You got to remember they're probably a 30 AWG, so they're like human hair kind of thing. On this, probably a little thicker than human hair, but yeah, the windings usually fry. Let's see, the static field is a dielectric field. Well, yeah, I can buy that based on the experiment I did. Yeah, I'm going to say that's probably true. So let's see. Non-static and dielectric are entirely different. Well, I don't know. When you want to do just a straight capacitor, static electricity is your worst enemy. But if you want to make the capacitor out of static electricity, it's your best friend. It really depends on which way you go. It's kind of the way it is. Boom, yeah. Sometimes. Yeah. Let's see. Do you have a base reference from Alexa to go off of on an RPM? No. It hurts? No. He gives you so many different numbers. Look, I think he looks at it and guesses. That's the honest truth there. I think he looks at it and guesses. So numbers he gives you, the best thing you could do is take your tape, match it next to his. Just like I did in the intro to this thing. Take it, match it right next to his, and see if you're in the ballpark. So usually what I do to check and see if the numbers, there'll be two magnets, like one on this side and one on this side. So one across from the other, and you'll see them consistently hitting at the same points. And that's how I judge the speed that he's using. Based on the motors that he's using, those are the speeds he has to get to. So, I mean, it's kind of a give and take on that. And if you run them any slower, it stalls out. Try to run them any faster, you blow the motor. So it's got to be right in the area that I'm in. And since the upper disc syncs to the bottom disc, when you set this one, to get it to just do that little bit of shake like that, just like that, you have to set this top motor. And that's why I set mine the way I did. I showed you in the video. When you set it like that, then you know you're right at the same point he's at. So the biggest difference is he knows exactly where his fields are. I don't yet. And once I know that, and I have that ultrasound worked out where I know I can dissolve this top field, we should start seeing some major progress in this. I think that's exactly where we're going to be. So hopefully that's soon. Trust me, I've been waiting for this longer than everybody else has. For everybody probably watching, it's probably been, maybe a year. For me, it's been about 3 or 4 years since I saw the first video. And, I've been hooked ever since trying to build this thing. So let's see. What's my process when I first start up? So first thing I do is I turn on my motors. It's going to take a while for that bottom one to gain enough speed in it. Then you set your top one. Top one takes no time at all. Once the bottom one gets up to speed, then you take your top one and you set it to that and you're good to go. Then the next thing I do is if the high voltage is on the inside, on the disc, then I start that up. And ramping it up or doing it slow, it's a pick 'em. Depending on how you want to test that day, pick what you want. I like to just ramp it up. Sometimes I'll use one flyback. Sometimes I'll use two, depending on the test I'm looking for and how strong I want the field and how much static volts versus high voltage I want. Two flybacks give me a real good static field. One flyback gives me mostly high voltage. And I can't usually lower the amps enough to get it to that static field that I want. So sometimes I just use two. It's really a preference thing. On that, Lexi only uses one, but then he uses capacitors in conjunction with it, I think. I'm pretty sure. So it changes the actual field coming out of it. So it'll change that. But the next thing I do after that is I start up the Tesla coil. I get it running. I check the fields, make sure everything's good and everything's on. And then the last thing I do is start up the piezo. And we're basically adjusting everything back to the center disc. So if you get resonance in this, it's where you want to stay. As soon as you get to the point where the Tesla coil turns on, the resonance parts or the actual vibration goes away. It is extremely difficult to get it back. So I honestly think when he gets this thing up to the point where he's just about to get it to level out and there won't be any more shaking going on, I think that's when he's hitting his piezo disc. I think that's when he's putting, everything into it and shooting it through it. That's the only time that you can do it where you still have that vibration before you get it to smooth out again. So I think it's right in there. I don't think you have to have a oscilloscope to do this. I think it's really pretty much on the timing of how it looks versus when he hits it. And there's like a 3 to 4 second delay. You count to 3 or 4, and then it'll make an action after you hit the button. So I think in that, if you start to see where you're good on all your fields and everything, and you start to see where it's going to, it's going to level out soon, hit that button a few seconds before it. And then that should be your first one and see where it goes from there. That's how I would do it. Let's see. Water has different properties than ice. Well, I don't even know where that came from. Okay. The dielectric is the field. Well, I think we went over that. You're saying in between the two discs, there's a dielectric in there. Yeah, it's an open air capacitor. So yeah, that is the dielectric. What is crazy is you're going to get a lot of forces of magnetism in there. It's aluminum, and you wouldn't think you would, but you're going to, from that high voltage from the flyback, you're going to get definitely some polarization in there. And it's going to be heavier in there than anywhere else on this whole craft, right there in that dielectric area. Let's see. This is my favorite project channel on YouTube right now. Keep it going. Love as someone loves gravity, concept of Graviflyer. I think we're all there, to be honest with you. I think we all just want the same goal. Let's just lift this thing off the ground. To be honest with you, if I found another thing that did it and gave us anti-gravity, I'd absolutely do it. But this is where we are right now. This is the closest thing I've seen to anything that does it. I haven't seen anything else that would have the correct capabilities to do it like this does. And this mixes, anti-gravity with resonance, with static electricity, and it's right up the alley of everything I like to play with. So this is kind of like the perfect project for me. I don't know the names. Steinman's? No, I'm not familiar with it. I can look it up, and we could talk later on it, but I'm not familiar with his work. So, okay, again, when will it lift? Well, when it lifts. I mean, that's kind of the short answer, and I don't mean to be rude when I say that. If it lifted today, if I could start it up right now and make it lift today, I would. Okay, I wouldn't hold it back from you. Trust me, I'm going to be over there jumping up and down. You're going to see a big fat guy jumping everywhere when this thing lifts. So I'll be happier than you are. Trust me. So let's see. Okay. You develop it once, everybody has success. Well, yeah, everybody's going to. Look, this is an open source project. So Arduino codes, you're going to get those. You're going to get everything. You're going to get so much information, it's going to drive you crazy. But yeah, I'm not holding anything back. As soon as I have it, you'll have it. And that's the way it goes. I'll publish every little bit of it, even the failures. And trust me, I've had a lot, and I could show a lot more, but I guess if you want to see a video of me getting shocked every 5 minutes, that would probably be funny. I know I'd probably laugh at myself, but it probably wouldn't make good TV time or anything like that. So let's see. Wow. I tell you, some of you guys have better jobs than I did. That's for sure. You're the head of GE Electrical Research Lab. Well, you probably have a lot more information on some of this stuff that I do. I get it based on testing. Um, Everything I do is based on testing. It's based on action and interaction and reaction of everything. So I have to have my eyes peeled on everything, guys. It's not going to be one of those things where it's like you know, it's just going to be given to me or something we researched in a lab or anything like that. It's going to be basically, you know, try it, see what it does, fails or not. That's what it is. And sometimes just a little tweak here or there, a little more interaction here or there makes it a complete success. I found that out when changing out uh, my Wilmhurst, whatever you want to say it is, changing out that machine for 2 flybacks. That was kind of a trial and error thing to get that. But man, did it pay off big time, and how it teaches you about electricity. So what's our Graviflyer? Uh, Isaac, what's that? Is that is that some kind of a site that people go on for this thing? Because I don't know much about it. If you can just let me know what that is, I'd go on it. If somebody asked me to go on any of their shows or anything like that, and talk about it, I absolutely would. We'll talk about different experiments. That I would as well. Guys, a picture of it in the air from the drone. What does he have a picture of? A Graviflyer? That'd be awesome. If there's something else. What? Oh, yeah, I missed part of that conversation. Reddit channel. Okay, I'll check it out. Reddit channel. Okay. Do I know about zero-point energy devices? Well, here's what I know. The whole object is to put out more energy than what you put in, right? So if I'm electrifying everything around me, I'm definitely getting more energy than what I put into it. If I start blowing things up, I'm definitely getting more energy, which should freak people out, because if I'm getting down to the level where it's 50 to 60 hertz that interferes with my TV, my high voltage is not that low at all. The only thing that low is the inputs from the wall when they come into, whatever power pack I'm using. That's the only thing that's at that frequency. That's why it freaks me out. And why it did freak me out, because your resonance point would have to be in the low hertz and not in the kilohertz where we think it is. And it would make more sense being in the low hertz, because of like Tesla's earthquake machine is in the low hertz. So it would make a lot more sense, but I would think it would be well below 50 though, maybe 20, 30 hertz, something like that. But I don't see that in this. But the interaction, I think it might be pulling from the wall socket. And over unity, I've always believed there's a way to do it when you do with Tesla coils and stuff, depending on, how much natural stuff you use from the earth. If you want to use saltwater batteries, stuff like that, then yeah, you can make something really good over unity. But the resonance over unity, is really super hard to pull off. I haven't seen anybody doing it yet. I may have been close. We'll soon see. I'm going to test that sucker probably about 2 feet behind me, and I'm going to see if I can light up my room one more time before I go outside. I got to test it to be sure. Do I need to damage electronics to see the field? Honestly, I think that Faraday cage may just show the answer. If I can find a way to make sure I can get some kind of a signal of energy through the Faraday cage from something to the outside, then yeah, I think I can find out exactly how much energy is there. Light bulbs, burn up, blow out. They do things, maybe even filament across from each other, different thicknesses. Which one blows at certain times might tell me exactly what I need to know. Different wires, when they fry, something around that level. Maybe it might be something that I want to check out to see where it is, and I can put those all inside the Faraday cage and give me an answer on exactly how many volts to blow it up. And that might work. It might not. I don't know. But I think I'll try that. Trying your ancient frequencies. Well, you know what? Love to. Well, somebody suggested that I actually put salt on this top plate and see what the frequency is. The top plate's so high to it, it'd be hard to find out. But I could take my second Graviflyer, take off all the other stuff, and just leave the center plate here and put a wire from this one to the other one, and it should transfer the frequency over to that. And maybe then I can get it to show me what it's putting out in frequency, maybe in the salt. Maybe it'll work, maybe it won't. I'll definitely give it a try, though. Yeah, LEDs would be one. I can see when they blow. Yeah. Yeah. Let's go brighter. Yeah. Okay, I can see that. Using a shielded cable. Alexi uses, let's see, from the wall, he is using the telephone cable. So there is a bit of shielding around it. So if I just took a Cat5 cable, cut off the ends and use the wires inside, I might be all right. Something like that. Or just find a telephone wire. Somebody, selling one on, yard sale, I could probably get it cheap. I don't want to pull it out of my wall, but yeah, Home Depot or something may have it. I haven't seen one there, so I'll have to look around some more. But yeah, that'd probably work good. Let's see. Yeah, salt's good. Yeah. Well, I hope it works. Yeah, I'm definitely gonna look up that book, Steinman's. I'll look into it. I probably can learn a lot from reading that. So from the way that you talk about it, yeah. Let's see. Okay, Don Smith used RF 2000 caps in his device to produce the temperature superconductivity. Oh man, yeah, it'd probably be way more electricity than what I need. To be honest with you, the key to this thing is that resonance and getting that field to just go around it. That's it. I don't need more power than that. As a matter of fact, it's a hindrance. Every time I try to overvolt this thing versus what Alexi did, every single time it fails. Every single time I do it, I run into more problems than what I want to have. And here's why. You got to remember, I'm getting resonance, eddy current, and two fields in this. I'm getting a static field and I'm getting my Tesla coil field. Everything that goes into this, it's more than just one thing. So it's the same with this top disc. I'm getting a resonance just from the disc running. I'm getting, high voltage goes in this. I'm still getting eddy current from the bottom to go to the top. So everything has an action and interaction with it when he does this. So overdoing one part of it to get it to be amplified better is a bad idea. It's making it so it doesn't work correctly. So I got to kind of stick with what he's doing there on some of the voltages. Now, does that mean I have to run the piezo with the same thing he does? No. Does that mean I have to run the high voltage with one fly back instead of two? No. But it does mean that I have to be careful about overdoing something. And it usually means a bad mistake. Yeah, I'm definitely looking up that Steinmetz. I got you. Okay. Let's see. What frequencies am I working with? So right around, what was it? I did a test on it just on the center plate, what it would normally put out. It's in the kilohertz. It goes anywhere from like 156, I think it is on the kilohertz thing, all the way up to 200, sometimes 240, somewhere in that range. It's getting in that area. And then and that's an abbreviated number, by the way. Anyway, yeah, it's right around there. Lately, I've been not using any kind of device on that because of the power I put into it. So unfortunately, I'm not going to give you a good number on that. Jared would be the one that you want to talk to about the numbers on this thing he uses his on pretty low voltage on that, and he's not trying to change the field. So if you look up my T-Brain on YouTube, you'll get every number that you want. So, hi from Norway. Wow. That's a long way away, man. Thank you for coming. Thank you for being part of this. Norway, the guy from Gold Rush, I think, is from Norway, isn't he? The blonde hair guy, Mr. Beats. So, let's see. I see 100-way AC solid needs to be perfectly balanced. This thing's never going to be perfectly balanced. I can create something that's perfectly balanced, and I can put it right on my shelf, and it look beautiful. And I could dust it off every once in a while. This will never be perfectly balanced. As soon as you run the motors on here for the fan motors, you'll understand why. There's a wobble in the fan motor like that, and you can't take it out. There's no way to take it out. When it runs at higher speeds, it flattens out, but there's always a wobble in it. There's nothing I can do about that. It's the way the motors are made. It's what he used, and that's the way it's going to be. Unfortunately, I with the other kind of motors, yeah, they're a little more flat and balanced, and you might do all right with that. But the speeds, when I put it on there, they go 500 RPM right away on the bottom immediately. They're not hitting the 3 something, and I have to go really, really slow. And usually the potentiometer is not; it doesn't have enough in it to get me down that low. So it's kind of hard. And that's I've changed different voltages. I'll have to put a resistor or something in the way in order to get it down to that, because they won't go. These fan motors are perfect, perfect for the right speed that Alexi's going. Let's see. High voltage, nothing that'll shock you much. Yeah. Well, the high voltage does shock you a little bit. Gives you a little bit of a bite. Don't touch it with 2 hands ever. With one, I've had some good shocks, but nothing that's nothing to write home about. Not anything more than the 110 out of your wall, and God knows I'm not touching that with both hands. So I wouldn't do the same with this either. So, matter of fact, touching with one hand is probably a very bad idea. I get intermittent shocks as I walk by it, kind of clumsily. So once in a while, kind of, cinch some stuff on your arms or something a little bit. So let's see. Yeah, I was thinking of a blimp UFO. Well, Tic Tac, I guess. That I saw some stuff on that. That might do it. I did an actual video on a guy a while back that was talking about one of those. Completely intriguing. He took the center of it where you're making your high voltage, and he created a vacuum chamber in the center, which I thought was totally unique and cool. And it looks like something I wanted to do as well. I just haven't had anything big enough to stand up to the pressure to, vacuum something like that. But that'd be awesome. What is that? Romania? I'm sorry if I said that wrong. I don't. Is that Romania? Is that where you're from? Wow, that's a long way too. Right on. Thank you for joining me. Let's see. Timing the voltage gradually, increase it to keep the stability. Maybe that might do it. I would actually look for an unstable though. I want it a little bit off stable. I don't want it. It'll flatten out way too easy at a lot of speeds. When you start running this thing, it flattens out. When I say that, it just means it's spinning and there's no vibration. And I kind of want the vibration in it because I see it in Alexi's right before it takes off. So I don't know. Maybe if it does the opposite and it creates, as you turn it up, vibration to go a little higher, I'm all for that. I think that might actually do really good. Using the AC light dimmer. No, I've never Oh, the Gravitucer. I probably said that name wrong, but I haven't seen that project yet. If you can hit me up later or leave something in the description, or excuse me, leave something in the comments for me later and just point me to where that is, I'd love to look at it. Good stuff. Keep working on it. Keep working at it. Yeah, thank you. Thank you very much to the alien scientists. Yeah, I'm trying. I'm really trying. I've kind of put off a lot of my projects to do this. You know, I like doing high voltage projects in a lot of different ways, and I had some cool AC flyback ones to do with a lot of voltage multipliers, and I put it all on the back burner to work on this. So, it'd be a lot different content on my show if I did all those. And I just kind of bought the parts and put them to the side because I've been working on this. So, bottom of Ukraine. Okay, cool. I'll look that up. My son is really good at maps. He could probably tell me in a heartbeat exactly where you are. Me, I not so good at them. I know the basics, and that's about it. So again, thank you for joining. Let's see. Anthony Scott, my toy maker. Let's see. The vibration from the radio of 2 versus bottom spin, no. Not sure what that means. Bottom is from the ratio of the 2 versus the bottom spin. Are you asking, is that correct? Or do I have a ratio for it? Well, if it's spinning at 300 and I'm doing about 800 or 900 on the top, somewhere in that area, then I guess there's a ratio there. Maybe 3-to-1, something like that. But I'm not into ratios and stuff like that. I just run it to where it works. So I think important you show even the most boring details because they show a lot and explains that words can't. Yeah, that's true. Some of the stuff, it could get really boring on how far I could put it out there. But, maybe I'll just make a compilation video and put all the boring stuff in there because I'll probably tell you, like you said, a lot more than what other people think is going on. Because there's so many interactions in this thing, man. It gets kind of hard to distinguish one from the other. And it kind of makes it sound like you don't know what you're talking about in some of your videos, but it's so interlinked. It works in so many ways with one another that it's kind of hard to say to only focus on this. And I try to, when I do the videos, just tell you one point because you'll get lost in all the different things that go into calculating this thing out. But, I think what it is, I'll start from start to finish on tuning it. Maybe I'll do another live show and I'll tune it live on air, and maybe that'll tell the story of exactly what I'm looking at. And then I'll hook, my oscilloscope up to it and everything else. And, maybe some meters to show you exactly what everything is and put that static meter on it. And then, hey, maybe the best thing is let's look for that explosion event then. Let's see if we can get that power out of it then. See what we can do. That might be pretty cool. So, he said top. You're just talking about the top. So, let's see. What'd you say? Vibration ratio. The top, how do I say this? The top will make the whole thing vibrate when it's out of tune with everything else. And that's what I was trying to say when you bring the speeds into it. The top actually vibrates at a different frequency until it gets set with the bottom. And you can adjust it up and down. It takes a few minutes to set because the eddy current's got to get back into it, and then it'll react. So it takes a couple seconds to get it to go. I'll tune it, count to about 5, and then it'll bring it into the Graviflyer and get it right where it needs to be. It's why tuning on this is kind of just boring and tedious, and it takes some time. Let's see. Then you were saying gravity is its own field. To be honest with you, I think it's a wave. It's kind of like a frequency wave that comes down, is what I think it is. So Alexi did not add any diodes. I'm sure that he didn't. Capacitor to the output of the flyback. Well, Charlie would know. He's got all of his stuff, so he's probably 100% right. Alexi drew it in the schematics because to show the data sheet for a DC flyback. Yeah, he was talking about the diodes up there on the flyback on that schematic, and that's not what I was looking at all. It's the way he builds his driver for the flyback is what I was looking at. It's different than what normally we would use off the shelf. Every time you put a pulse rate in this, it's a little different. So let's see. Can you explain what happened in more detail from the last video about the major electricity pulse? What did you see? What are you thinking? So you see this box behind me, right? So I pull out this drawer and I basically say this is my motor driver. Obviously it's not, but say it was sitting right here, right? That's about where it was. What would happen is as soon as I turned it on, because I put in the Tesla coil was already on, okay? And then I plugged in high voltage to full strength, okay? Right away. Didn't go slow, went full strength. What you got was like Rice Krispies everywhere. So it was hitting here. It was on those 3D printers, snap, crackle, pop, every which way. Okay, everything. I have bolts in here popping to the next bolt, and everything else inside this. Then you'd see the TV. It started to flip out. It started flickering just like this, and then on the top of my screen, like you see your web stuff up here, and you got your different channels. It would literally flip from channel to channel to channel and just do its own thing. It was like somebody else was playing with my computer while I'm sitting here. So as soon as it started doing that, because I've blown out 2 graphics cards messing with this stuff, I just shut it off. It wasn't worth it. $500-600 a pop for a graphics card, man. It's not fun to replace them, and I didn't need that kind of a mess going on. So I just went ahead and did it. Turned it off. Thank you, my T Brenda. How you doing, Charlie? Both you guys. See, Charlie says he's still having trouble building Alexi's flyback driver circuit. It draws too much current, and yeah, I can believe that. Especially when you want to get it to a static volt. If I just want a high voltage, man, can I make a circuit for that? And it makes some raging voltage. Matter of fact, I might even try to take my AC flyback and throw it on this thing and see what a voltage multiplier do. I'll do it when I know the motors are getting close to the end, though, because I should have built it a better way, because this thing is a pain to get to change those out. So a little quick connects would be a lot faster, but I don't think it'd be as stable. Let's see. I worked at LIGO. Hopefully I said that right. Gravity is a wave. So there you go. So that's what I think it is. I think we're looking at waves coming down, and we're looking at this thing creating a field, so the waves go over or in around it. And I think they come back on the bottom. And I think this right here is disrupting it in some way. And it stops it from putting pressure on it. So what you're getting is 2 different things in this, by the way. You get a lift factor, you'll hear me say, and then you get a thing to break gravity. So I believe the resonance in it is going to break the gravity along with the static field. But I think the lift has to do with the piezo and the Tesla coil. So, or piezo, sorry, not piezo, piezo. Anyway, I think that's how it breaks down. And that's the kind of what I'm going off of it. So it's just 2 different factors broken up, and we'll probably have to do some individual tests on each one. And I can tell you from working from the static electricity angle on stuff, definitely a field that can break the gravity and allow things to force up. Again, I would tell you to look at that paper lifter experiment I did. If you build it, you'd understand it. And it would just be something that'll trip you out beyond belief on how much pressure that puts on it. So And it might be the interaction with that, with the piezo and the actual field inside between these two discs, which is giving us that force up once it breaks gravity. Because I think this thing honestly weighs 3 pounds here on Earth, but if I put it in between two planets where there's no gravity or only the gravity of the sun on that area, this thing might not even, weigh in grams. So it would be a much different weight. And then the force of that static going up would actually drive this thing up without a problem, if that was the case. So we'll have to identify those individually. Yeah, pulse wave. Yeah, you know what the funny thing is? On every one of these devices, it's all pulsed. All of it. None of it is a straight volt. It's all pulsed. So it kind of tells you about things working better in a pulse wave than it does in anything else. Yeah, definitely agree. Pulse wave for everything. Way better results. Otherwise, you can't really hardly anything. So let's see. What else do we got here? Oh, you guys talking to Charlie? Yeah, okay. Let's see. Very hard, though, because most are just people saying quotes and all. About the original information, Charlie's the guy to see. You see him in the chat here. That guy has everything. Okay. Yeah, Charlie, I have another Gyroscope. I showed it once, actually, on the channel. I was running through some frequencies of the center plate. But yeah, if you want some good information, Charlie C is the guy to see. Jared's also very good at my T-Brain. He's got a lot of information on this stuff, guys. They talk to Alexi directly. So, to be honest with you, those are the guys that I talk to that have the most information, and they've been very good about giving me a lot of stuff that I needed for this, and I thank them both for that, because it really has taken my research to another level, because I was stuck in the high voltage realm, and I realized it had to go to low voltage to get this done. So in the stuff that they did and the tests they did, mind-blowing. And then Charlie stepped up and got me that ultrasound circuit that was just awesome. So honestly, Charlie, I bought a bench power supply to go with that. So just like you, I went in about the same one you got, and we'll find out. I'm going to put a little more into it. Maybe I can dissolve that upper field. So anyway, yeah. Let's see. The food being okay. So you want to know about gyroscopes or gyroscopics in the bottom. Are they weight cancellation? No. If anything, on this, to tell you the truth, when you get into gyroscopics, they hold the position they're at better than anything. It'll wobble slightly. So what you're seeing is a stabilization factor when it lifts. You'll see it wobble slightly. And that's the stabilization that you're creating with the bottom magnets because it's heavier. That's what you're getting there. That's the spinning and the weight on it when it's spinning. That's what's keeping it level in the air. It brings it back every time to where it likes to sit, and it likes to do the same. You can basically take this bottom disc in your motor and hold it, and you'll find out it puts a lot of pressure on your hand, and it likes to stay in the same spot. It moves just slightly, then moves just slightly. It's like it's floating when it goes and does that. So it's actually, it puts a lot of pressure on it though. So what I don't like about it is it may push pressure down. And I don't know if that's a good thing. If it pushed pressure up, it'd be perfect. I'd love it. And, maybe a whole different thing on this, but yeah, it kind of, that's also another thing on this. It has to be a slower disc because you cannot move that thing up if it's too much on it. And like I said, you just put it in your hand and check it out. When you try to move it up, you're going to have big problems when it's spinning fast. If you're at several thousand RPM or whatever it is, no, it's not working for this. you have to be around like 350 to be just in the right, frame where it has to be in order for it allow it to lift. And I don't think a lot of people understand that. And it's not till you hold the motor in your hand that you're going to understand it. So it's just going to be one of those things that's trial and error when you get your own and do it. But yeah, it has to run really slow. So that's probably why Alexi used these motors that he did. Let's see. Charlie says there's an interaction with the ultrasound when I turn on the AM radio with a static channel. I believe that. And here's why. Remember I told you about the hertz, right? In being low hertz. And I thought it's interacting with something. I totally believe that's probably what's interacting with that AM radio station. Somewhere in there in that bandwidth between going back and forth with the eddy current hitting it. I bet you I got dollars to donuts, man, that says that this disc right here is getting at least 6 to 8 frequencies in it at one time. And I bet you the AM radio station's in that frequency range. When I did it on my 3D printer, the reason I show that test is so that you guys can see the different ranges when something's in resonance. So I pointed out, 6 frequencies, but there are about 12 or 13 in there that it hits. So some of those are right there in the AM frequency range. So I don't doubt that whatsoever. It's the resonance of the aluminum that's causing it because you're getting so many frequencies in it. Let's see. Do I have a plan to make a bigger version? No. I made a smaller one once. It was yay big, probably about the size of my upper plate was the center disc, and had no luck with it because the motors would fry. As soon as the high voltage hits it, motors fry. So no on the smaller one anymore. Bigger one, no. As soon as this one lifts, guys, the next step's going to be all yours. Take it where you want it. I got some TT Brown stuff I want to work on after this. So, that's going to kind of be where it is. It's going to fly, and I'm going to do everything in my power to do it. Let's see. My T-Brain says I had kind of a similar EMP instance when the Gravitational tipped over. Oh, really? Yeah, real bright on the bulbs. Yeah, shorted out to the mid plate. Well, I didn't have a short in mine. I think the two interacted at too high of a level. And I think they hit a frequency zone in here that just immediately was right on. I think I got the luckiest thing in the world to find this test because I think I had it just right in the resonance point is what I think it was. And when I hit that high voltage, I had it just barely shaking like that. And if I changed the upper disc just a hair, it would flatten out, and it was just right. And I think it was right there, ready to lift. Boom, hit it in there. And I probably should have went slow and built it up because it was probably too overwhelming at one time. And that Tesla's coil said, nope, you can't come in here. Boom, blew it out. Yes, I do plan to see the what it is on the Tesla on my Tesla coil to find you all that. I've been just trying to find out how to do that, and that's all there is to it. I've been waiting for a frequency generator to get here so I can get the exact frequency of it and line it up. I've seen people do that online. I think my T-Brain uses a wire next to it to get it. I've also seen a hoop that goes around it to do it. I'll have to get with one of you guys and figure out exactly how to test it. I believe I have all the parts here to test it. So, if you guys help me out with that, I'll tell you exact numbers on everything you want. I see you just open sourcing the knowledge. Well, the other guys that are working with me are doing the same thing. Look, I don't even have my channel that's not open. My channel is open source. So you can take a video off it if you want to. This is basically, just research I'm doing. I'm having fun doing it. You know, it's my hobby, it's my passion, it's what I like to do. And you know what? It's all open source. So if you got something that you want to disagree with, you want to make a video about it, go right ahead. I'd love to watch it. Send me a link. You know what I mean? If you got something you agree with or want to improve upon it and you want to show you doing it's yours, by all means, send me the link. And I don't mind going back and forth with everybody. Nothing bothers me, guys. It's all the only one that bothers me is the string people, the fishing pole people. I can't get it out of my head. I'm sorry. Just irritates me. But other than that, not a problem whatsoever. Don't mind going back and forth on anything. I don't have to be right. And a long time living man, it just tells you you don't have to be right in anything. But what you do is you have to get the right answer when you get it, and then share it and have people verify it, and then we're good to go. So, even if I get this to lift, it still has to verify, through other people. So just understand that it's not going to be Nathan gets it done, walks away. No, it has to verify through other people so we know that we all have it. So. Here we go. My T-Brain says your high voltage DC was shorted to the frame, which makes it way easier to short to circuits nearby, like the house line, TV, printer. Yeah, I believe that. I definitely believe that. Yeah, workbench would have been conductive enough. It may, to be honest with you, I had the Graviflyer on the ground, so it would have had to travel from there to the workbench. Okay, so I know it's pushing out the field. No matter how it comes out, it's pushing out the field. So did it have enough to create that and make that into an antenna for the whole room? It might have. It may have been bigger than it needed to be. And maybe. Yeah, it's the instant rate of how fast everything got charged. This isn't one of those things where it built up. It was not, do a couple tests on this thing. It's the first test of the day. I walked out. I came in here at about 9 o'clock in the morning to do a test on it. Nice and sunny out here in California. What wasn't, damp weather or nothing. Within the first second that I plugged it in, pop, 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 pop. I'm thinking, let me look at my Graviflyer. Maybe I'm seeing something cool on here. You know what I mean? Let me grab my camera. So I should have had my camera set up in the beginning. I know that. I didn't. And the next thing I look over and I start seeing things sparking. And this thing is not lightly sparking. It's heavily sparking. Okay. It's where you can see it and everything and you can hear the pop. So it was immediate. So it just kind of immediately out to everything. And all I could think about is, man, I just spent a lot of money in here on new equipment and I really don't want to blow everything up. So yeah, just a little different. Okay. Yeah, ionized pulses. Okay, or longitudinal pulses are the key to IMO. Yeah. I tell people that all the time that you got different waveforms going in. Most of the stuff goes this way and, just waveforms to it. This one's got to come down. And it's why everybody puts it as their lift factor as part of it, is because of that, because it's the only one that pushes down. And if you notice on the bottom of this thing here, let me get in the right picture. There's no, I took the cone off of this, which is just plastic anyway, but this on Alexi sat open. And I think I seen one that Charlie had where it was all sealed off with metal to each one, but his original one was open like this. So I don't know if he had a problem with the piezo conducting through it. I didn't see the other ones lift, and then he sent them to Charlie. I don't know if Charlie got that on there as well as part of what he has on there. But that would definitely be interesting if you saw those lift that are built that way, and then you got them. So I would definitely, if I bought one from him, hey, show me it lifts in the video. We're good to go. I'll pay the freight on it. Let's get it done. So. The resonance that I'm talking about in the center disc, okay, is, I want to say it, you're getting a vibration that's moving the center disc slightly. It's not very heavy. Again, I use rare earth magnets, so I've gotten rid of a lot of the eddy current that goes through it so that I can see exactly how much is going in here. The resonance in there is just like your 3D printer resonance. It's going to show on an oscilloscope more than it's ever going to show in person. So the amplitude on that is something I'll have to test and give you the number on because you're going to probably want to see all of it. And I should probably just run a test and put it on my channel for you, and then you'd have all the information you could want. But it's definitely different running different magnets on this than it is running the neodymiums on it. I even thought of putting even a little smaller neodymiums on this just to make it a little better, just so the weight factor versus the amount that I'm getting in my center plate. I found that when I ran the transducer on the side and put it into here, I had a lot more problems. So it was the frequency was just like all over the place. It's uncontrolled frequency, I guess you could say. But between the two discs, it makes a better frequency. So, let's see. I don't know who Dr. Bueller is. Are you making a joke there? I don't understand. Parts can't come fast enough. Yeah, I'm really looking forward to that. B27274. Been working on this thing, getting parts for a while. So I hope you get everything, man. I want to see it up and running too. Oh, that's interesting. In the days of the wooden boats, the top of the mast would discharge with electric glow, a phenomenon named as St. Elmo's fire. That'd be cool. You know, I wish they had one of those around here. I'd love to see it. I'd love to see it light up. Hell, anything that goes on there that shows your voltage lighting up, I'm in, man. I'm there for it. So I didn't get any numbers when the power burst happened. It was sudden. Like I said, I didn't even have my camera hooked up. So I'm going to intentionally do it this time. I'm going to hook up my backup computer with the cheap parts in it. And God help my TV. I'm going to try to put all my printers and stuff to the side. And let's light them up. You know, the only way we're going to get progress is to try. And I don't like not trying. That doesn't go well for me. So let's do it. Light them up, man. Let's have it. Oh, electrostatic guy that works with Drew from Florida. Really? You know, if that electrostatics guy actually looked at my paper lifter, it'd probably give him a lot because I can create a lot of force with that right there, my T-brain. It would really be a lot. I'd actually like to see the force he's getting out of his versus what I get out of mine in a vacuum chamber because I think I could stand up without all the expensive parts. So let's see. Am I open to funding for parts to speed up my testing? Yeah. If you want to, man, whatever you got, I'm there. I mean, within reason. I mean, I don't want to waste anything, you know what I mean, and put you out too far, not in any way. But, if you guys got something secondhand you don't need or whatever you want to ship to me, that's great. Circuits or something like that, awesome. You know what I mean? But yeah, I'd definitely be up to increasing what I do. You guys saw I got the little static tester in here. I got the one that Jared said to get. I also got the oscilloscope. I also got a couple of what is it called? Voltage meters back here. I got a couple of those. I got some old personal stuff that I made. to test out stuff with some static electricity and stuff like that, some circuits. So yeah, but if you got something, let me know what it is, and we'll work it out. Great studio. Yeah, this is my garage. My wife had almost a heart attack when I started changing the stuff behind me. Um, I I went in here. That's her laundry room behind me. I closed it off. I got tired of hearing that sucker. Yeah, I didn't want to hear that washer and dryer no more. So I just recently closed that off and painted it. I still got work to do. You can see it, baseboards and stuff. But yeah, into the Batman thing. If I could show you the wall that I'm looking at, it's way cool. It's like a 3D, like a halo type wall, mixed with a lot of different cool things. It's all pops out and everything. It's all black, kind of like Batman. You know what I mean? Just pick your shade of black. That's what it is. So it's really coming together. Hopefully, I can keep it nice. I'll probably do a video and show you the whole rest of it, because you trip out on just the wall of printers I got sitting right to the right of me that I prototype things on all the time. And some of the other stuff that I got over here, it's just really cool. I just sold off a laser printer and a CNC machine because I'm tired of getting the dust in here and dirt and all that other stuff. So anyway, hide my basement, then my garage when I'm drinking. Yeah. I gave that stuff up, man. Too much trouble. Kind of gave up all of it. I've been trying to lose some weight. I lost 60 pounds, man. So I'm trying to lose a little bit more. So none of that stuff for me. But those days were fun. Let's see. So let's see. Anthony Scott said, oh, he's working on a cool project. Yeah. Let's see. I'm going to do new coils, smaller pancake design, and more compact. Look for more flying saucer. Yeah. I want to see that. I want to see it when you're done, man. That'd be cool. That I've seen some of the stuff. It looks really cool. So yeah, should be more efficient. Yeah. Oh, let's see where we at. Poor TV. Yeah. I probably should change that out. I look at a 55-inch TV because I'm getting old. So yeah. Let's see. What other tests do you want to do to the Graviflyer? Well, first things first, I got to get the field contained. And it may have been a fluke last time, may not be. I want to do some testing on it. I just want to see exactly how far that field can come out and pulse. And any kind of testing in that direction is where I want to go. I want to get a pulse field around the top plate and the bottom plate, and one right around the center. And these right here, I want to know if that Tesla coil is getting all the way through it. I don't know if there's a better way. I put the light next to it, and it's on and off, on and off. And then this top part, barely at all. I get it good right here. I get it good right here. But this part here, I'm not getting a whole lot out of. So if there's any tests you can think of to do on that, that's something I need to look into for sure. Let's see. While studying Don Smith's device, he mentions that the voltage in the air runs between 50,000 and 1.5 million volts. If that is the case, how do you see the Graviflyer reaching to this? I don't think it's going to get to that level at all. And quite frankly, I don't think it has to. I think it's interaction between the static field and the resonance is what I think is giving you your anti-gravity effect. And I don't think it has to reach high voltages at all like that. It's not big enough for those kind of voltages. I mean, I can see if we're making one the size of my Dodge truck or something, then absolutely, man. We might get up some good voltages there, but not with this. This is too small. Okay. I have an eBay and Amazon shipments on the way. TT Brown and James King. Okay. Experiments are coming. You know, love to see them. I love to win that money. And I think I have the device to do it. And it may be in static volts, though. I don't know if that's even going to be okay with what he's looking for. But I could definitely prove that you're moving things with force with it. So even if I don't win, I definitely have a better experiment than most people would see what it is. Okay, KDM physics. If anybody has a schematic to that, I want it. I absolutely will pause doing some of this stuff to put that together. I don't mind spending a day or two doing that. Absolutely love it. Anything you can get lift off that, I want to see why it's doing it. It'll just help in this device right here. So anything on that, absolutely. Send me the diagram. I keep seeing his videos and he keeps saying he's talking about it, but talking about it and giving me circuit directions are two different things. You know, give me the layout, give me everything else. You know, get in depth, show me every little nook and cranny of this thing, kind of like you guys want to see with the Graviflyer. That's what I want to see of that. But yeah, absolutely, Charlie. I want everything on that. Oh, you're gonna email to me? Oh, yes. Oh, well, let's put it to the test, man. Let's run this thing. Absolutely. Have you tried a negative ion generator? It's almost the same size as the flyback. No, I have not. I would like to. If anybody's got a way to build that, send it to me. I'll do it. I would like to do negative because when you get into static volts and stuff like that, when you charge up a pole and put it to an aluminum can, you're getting negative off of one of them, and I'd love to see it. I'd love to play with it just to see what it does. I'll hook it to my Graviflyer for sure. Let's see. I think it is the air interacting with the charge too. It's dielectric. Well, yeah, there's obviously an interaction with the air. Look, this thing won't work if it doesn't interact with the air. So space, no space, I don't care. This thing has to interact with the air. It has to. It's going to have to charge something. I don't see anything else in the air it's charging. So it's going to have to charge the air in some way or another. That's why I think the static is more the better field, because the Tesla coil charges the air, but not in the same way that the static does. And I don't know a better way to say that. I would like, what I should have done on my flyback is use the negative side of the coil to put on the field on the outside. I think I'll do that next time. Maybe I can get it to pull in that way. And if I can, then we got something. Please email to me too. Yeah. I think everybody wants to get that device up and running. Everybody likes the physics guy. So you have some extra one you can send me. Dude, shoot me an email. oldmannathanbunten@gmail.com. I'll leave it in the description later on. But I definitely would love one of those. The airflow test, yeah. You know, there's not much airflow, is there? In the fog, there's nothing there. This thing could sit right next to you. You never know it's there. Never know. And the cool thing is now we're building fields, I'll do that test again. Because if I can feel that anything is sucking into the field, let's put some fog over it. That's why I wanted to do the chamber in the first place, is I wanted to see what fields were pulling in or pushing out, if there were any. Maybe a little bit of glow on anything that has a high voltage on it would tell me a direction on which way it's going. But yeah, the air test, the fog test, I'll do those again. Once I feel I got a feel on it, boom, let's do it. You know what I mean? That was one of the funner tests, though. You don't want that stuff on your computer, so you kind of have to get a good airflow out your garage. So, see, I am experimenting with it right now with a negative ion generator. It's yielding some result, but we're waiting for the ultrasound. You know what? Get a hold of Charlie C. See if he can't hook you up with that ultrasound circuit, if that's what you're waiting on. That, negative ion generator, that's going to tell us a lot. If it's bouncing anywhere off the ground or anything like that, or pulling up, it would be a big help to find that out. Okay. Jeremiah's working on that one with the, I can never say that name right. Kidium? Is that right? Kidium physics? I'll try that. I think everybody here on this channel would probably try it. So send it to me. I'll send it to everybody else, and we'll all blow this out and see if it can work. If that guy says it's okay, if he doesn't, then I'll hold back on it. But let's see. 2 coils, just the primary side. Well, yeah. Just went and got my disc recut. Okay, smaller diameter. You're going to increase the bending force. Okay. I don't think the bending force is going to be much on the lift because they flatten out a lot. The bottom one, you can't get the bending a whole lot on either way you do it. But do you really think that the outside, that little curl is giving the lift? I mean, is it because you're thinking there's a force in between the small plate and big plate that's forcing it up? Or is it something else? I mean, I could see that if you took the inside, because you got a magnetic field in there. Whether anybody knows or not, there is one. And if that's what's pushing the aluminum up like that, then yeah, I think you're right on with that. Let's see. A lot of ozone was a negative generator. Yeah, the times I did all this stuff with ozone, man, no mask is going to help you. Putting it in a box and blowing out to the outside is what you need. And that's part of why I'm building that chamber, because I like to do those experiments, but they give you such a headache. And, after having a headache for the last 2 days, I finally got it cleared up today. Yeah, I can see what you're talking about. Let's see. Where to buy the disc? I'll say this to you. If you have a Lowe's home improvement store next to you here in the United States or anywhere else, or you can order from them, they have this stuff for these discs. They have it in stock. I have it on my build video, and I even give you the UPC code or whatever it is on there with the name of it, so you can look it up. So yeah, you could definitely get it from there. That's where I found mine. I don't know where Jared found his. I think he told me once. I just can't remember. Gotcha. Okay. The centrifugal force of the magnet causes them to bend outwards. Smaller, less bending. Yeah, mine don't have much bending in them at all, to be honest with you. Once they're flat, they're flat. And I used the same sizes that Charlie did in the original Graviflyer. That's what mine's based on. And if you saw the intro video when they're sitting next to each other, they're pretty similar, except for I don't have that bend on the end. And that still bothers me why that's there. Why you wouldn't cut it off or flatten it out. Those it is. Yeah, that's where you got to go. Yeah, orange peel. Yeah. So everybody's going to be at Lowe's buying it out. I won't be able to get any for a while. Well, if you're in California, you might see me in there. So let's see. Let's see. What if the plates that spin have to spin in opposite directions if they don't already? Look, so let's look at this. These right here are fan motors. So the fan motor is only going to spin in one direction. So being that they're opposite of each other, pushed into each other, right? One goes this way, the other comes back that way. So they're automatically going to be set to counter rotation. They're not going to go in the same direction at all. Automatically, you'll be set to counter rotation. I haven't messed with it. You can't get them to go the opposite way because of the actual circuitry inside there. So counter rotation immediately is what you're going to get, and that's what you should stick with. Let's see, 1 to 2 millimeters of bending of dead vertical, 1200 to 1800 RPMs. Hey, Jared, did you see the intro video into this? I put my Graviflyer next to Alexi's and showed you the motor speed of the bottom. And I think I'm right on, right around 300 RPM, 350. That's where he's at. And then I also showed next to each other when his lifted and mine just had the vibration just like his did. And you can see it right there. I think I'm right on with the with exactly where the discs have to go and how fast they're going, because the bottom one dictates the top on how the speed goes. As soon as you set the bottom one, you're going to find a spot that actually allows this to vibrate, and the rest of the time it won't vibrate at all. And that vibration point is where I set mine at. Yeah, I'm talking about my comparison that I did. So I'll just put it on my channel and you can take a look at it later. But the motor speed would trip you out on exactly where it is. And by the way, if I were you, Jared, buy some of these motors and just run them, and you'll see why. He can't get those speeds. Not the speed you're getting. He couldn't get to them if his life depended on it with these motors. Maybe the top one, he can get it up over 1,000. Not the bottom one. Not in any way. Any interference in it, it's likely to stall out. They're that weak. Wheels falling off a Boeing airplane. God, the news lately, man. They are just taking a drubbing. Oh, it's bad. If they thought I'd be using a left hand wound for, sorry, I can't see in the bottom right there. Oh, here we go. Okay. A left hand wound for rectal solenoid test coil. So wind it to the left side and it'll put out negative only. So like this, left way around. So if I'm looking at it on a clock, it'd be clockwise. Is that what you're looking at there? My Tesla coil is clockwise. So if you laid it clock flat down, it'll go clockwise just like that. And that's the way the bottom is. So whatever the roll is, the wire comes in, whatever they're set to, it's opposite of that. How much interference to get to 650 RPM? Probably a lot. No interference whatsoever. They couldn't have had anything touching on it. But 1150, yeah, on the top, I could believe that. But you still turn them down when you set them. That's probably the max RPM. So negative on the coil. Maybe that's what I have. I don't know. I'll have to check it. You know what? I'll just build a second coil. I got the parts. I'll just build a second coil. We'll do one to the right, one to the left, and let's see what we get. I think that's probably the fairest way to do it. And see if there's any different effect on it. Let's see. How do we know it's not just air lifting up? Well, you probably didn't see my fog test on anything. It'll tell you exactly how much air flows in this. I get more from a PC fan than I'll ever get from this. So, and that's the worst PC fan. Matter of fact, the little PC fans that I use for this put out more air than this thing will. So it's barely moving the air at all. Barely. Looks amazing. Well, if you're talking about mine, thank you. Yes, I am 100% positive the plates are aluminum. And I believe Charlie got his tested, the ones that came from Alexi, and they're aluminum. Really? So my T-Brain, nope. There was RPM using all Alexi settings. Well, that's interesting. Definitely interesting. Did you hit the point where it started to vibrate and then thinned out, and then you could set it back to it on just by changing the top plate? I'd be interested if you did that. Let's see. Part number from Alexi's kit motor say that the spin there's no, I can't get 4,500 RPM out of this at all, Charlie. It might appear to be fun. You know what? Here's what I'll do. I'll just put my laser thing on it and I'll post it on one of the things on here so you can see it. But it's slow. It's really slow. Matter of fact, it's stall out slow if you put too much pressure on it with the brushes. Let's see. So if lifting itself up by its own bootstrap doesn't break some sort of scientific principles, well, it's the part that we don't know. Why why can you put horses on a bridge, multiples of them, and it creates a vibration that takes down the bridge? We don't know yet. And I think that's what resonance does to things. It sets things out of balance with Earth. And I think that's why it's doing what it's doing. It comes down to that resonance. And like I said, there's probably, we'd all like to say there's one resonance frequency, but I'm probably thinking there's about 15 in this that goes through here, 15 frequencies. And somewhere in there, they find a resonance point. Jet copper, never. Oh, sorry. Jet copter. Well, Jet Cooper. Okay. Oh, yeah. He said they're aluminum. The legs on the things are stainless steel. Really? That's more expensive than the cheap, zinc covered ones that we normally buy. Huh. Maybe he's getting more conductivity out of that. I'm gonna try that. Let's see. What's the transducer for? So if you're talking about the little piezo disc that's, sorry, I keep whacking this thing. Up in here is that little flat round piezo disc. What's that for? Is it creates a wave that goes up and down. It is really what it is. And it's pushing upon all the eddy currents and the all of the resonance and everything in this thing. So as it pushes down, it puts a different frequency into all of them. And I think my Jared, my T-Brain on there, he was talking about it interacting with the Tesla coil field. And it was creating a spike in it, or it was going along with it, as I saw in his video. And basically, I think we've all come to the conclusion it's for lift. It's the only thing that's pushing something. So let's see. Let's see. You also use a magnetic stretch pole and a tiny articulating bar magnet to see the fields, or a field meter. Really? I didn't know that. Did not know that. I just got the machine. I have no idea. That's what you told me how it works and what I've seen online, man. I don't know much about it. I've only used it a couple times. Yeah. This bridge shows how much frequencies difference in constructions. Yeah. You don't want the wrong frequency and stuff. And I think that's what Tesla was trying to tap into when he taps into frequencies everywhere. Is he knows there's a frequency value for everything, and he probably knew it was multiple frequencies, and that's why you see that his earthquake machine, it makes multiple frequencies. You don't think it does, but at the top it makes two up there. On the bottom, it takes two. When you take a steam and you hit it into something, it'll make a pulse wave. When you take water and hit it into something, it makes water and makes a pulse wave there. So you're getting a lot more out of that than you ever thought you probably could. But it's multiple frequencies and pulse waves that come out of that machine. When they just have a vibrating table, that's a joke. That's not what it was intended for. Matter of fact, you wouldn't see the vibration until it got too much where it tears something down. Then you'd really start to see it. Sonic resonance, 17,820 hertz. We'll have to put that to the test. Let's see. With ferrofluid, you can see the magnetic field in real time. If I'm not mistaken, ferrofluid is the black fluid that has the ferromagnetic pieces in it. We're looking at a field to go over the whole thing, and I guess you can cover it in it. I don't see the use in that, but I guess it would show something. Let's see. Yeah, that should be different than steel. I don't know where that conversation was going right there. Ferrofluid in a container. Well, that'd make more sense. Sorry. Yeah, it'd probably make more sense. And then put it next to it and see where it pushes on it. Now I got you. Now I got you. Yeah, I have to make some of that up then. See how it's done and put it together. Yeah, I do have a plan to put it outside. I absolutely do. And I'm going to empty out my garage because I have some painting to do. So it's a perfect time to run it in here. To get the test in here to test it one more time. And then, yes, I do have a place outside. Unfortunately, it's going to be in a field away from everybody, you know what I mean, where there's no high voltage lines around it, because that would be bad. Did I explain the paramagnetic fields on the aluminum center plate? So right here on the center plate, when it went crazy in here, just so you know, it was feeling like the center plates was magnetized. And that happens usually when I do a static electricity experiment, just like I did with the high voltage coil on my flyback to the, what was it, the aluminum, how it sucked it down. Same effect here. So when I was moving my light around, they had the metal ends to it, right? Neither one of them, I think it's aluminum on there too. Nope, magnetic effect right to the top plate, or to the center plate right here. Same magnetic effect. It didn't blow it out because my motors were fried. I put I showed it on the video where it lit up based on the two fields together. But what I probably didn't tell you is it magnetized the center plate, or put a polarization on it would probably be more accurate, to make those two things stick together right there together. And that light bulb, the end of it on those fluorescents, stuck right to it. Not a problem. Oh, cool. Thank you very much for emailing me that. Yeah, I'm going to need those. So, hey, also, Jared, if you have a way to test your Tesla coil that you like, if you don't mind, put it in your next video or whatever you want to do. I'd like to do that the same way, so I could tell you exactly what mine's doing. Let's see. I saw let's see, experiment. Okay, test with the ion filings container covering the disc. Try to find it. If you find it, send it to me. I'd love to see something like that covering the disc. This was awesome. Well, hopefully we'll have to do this again, guys. Like I said, I'd like to do some tests on the next one. Um, we'll just get it going. Whatever we have to do. So, gotcha. I don't know which polarization it was. I have a magnet tester. I'll try it on there and see what it was. I I I have a think. Excuse me. I have a thought that it just polarized it to one another, kind of like the wood did. It just found its match and sucked it to it. And I can't say any other way than that. I will field test it though. When I when I go to do it again, I'll field test it. Yeah, for sure. Okay. Yeah, show me some pictures of those fractal coils. Interesting. For giggles, can you put a watch near you? Do you guys really think it's going to change the time? I mean, I'm all for it. You know what? I'll put a clock next to it with a second hand on it, and we'll see if it stops, goes backwards, does anything. Look, I'm all for trying stuff, guys. I'm all for it. So yeah, you got it. That'd be funny. Wouldn't that be something, huh? Would it screw up the camera clock too? I wonder about that. I mean, would it tell me I'm in a different year or something? That tripped me out. I'm sure it just messes with electronics, and it might tell me that. So I'd have to find something that's more, I don't know, like an old school clock with quartz in it. I might have something like that. Might be better. I think a digital clock wouldn't work at all. So put it on the live stream. Okay, cool. Yeah, I want to get that tested out. And I do think I have my Tesla coil wound backwards to everyone else, to be honest with you. And it was a reason I did that a while back, and I don't know why, but I did. Conductive effect, yeah. Could be. Anything I get out of this in one way or the other, guys, it's a direction to go in. Just like everybody else, every little piece of data means a lot. So any more that I can get one way on this, one way I get the other, either prove something, disprove something, gives me something to work on with something else, then I'm all for it. Because I think, honestly, that's what it's going to take. It's not like this thing's plug into the wall and be happy it's flying. It's never going to do that. Well, not until we figure out everything, then it might, but not until. So we're going to have to try everything. Just kind of throw everything at the wall, see what sticks, and then pull all the numbers out you can and do it. Weekly, please. Well, you guys invited me on your show, and I'll come in there and do that as well. But if you want me to do this one weekly, yeah, I could do it. My daughter was in here trying to help me set this thing up, driving her nuts to do all this stuff because I have no idea, past the generic version I'm running right now, what's going on. So might start to go to StreamYard, stuff like that, and get a little more accurate what's going on, you know what I mean, with everybody on the live stream. So absolutely. Oh, let's see. Think tank, yeah. Well, that's what we do. I mean, I was just out there with everybody, a day ago or so, and we were on ASP. I keep screwing up the letters. APEC, ASPEC, whatever it was. Aspect is what I believe the name is. We were on there, and it was a think tank. So yeah, I'm all for those, man. Anything that gets it closer to where we need to go, absolutely. Backward land waves. I have to look up what that is. I don't know much about it. Huh. Probably talking to the other guy. Sorry. APEC. Thank you, Charlie. I have very bad problems with names. I can remember voltages, things like that all day long. Names, no, can't. Alternative Propulsion Engineering Conference. Thank you. Yes, I feel bad for screwing that up now. Thank you. Definitely. All right, guys, you got some more questions here, or it's been 2 hours? We could pick this up again next week if you want. Matter of fact, let's probably do that. Let's pick it up next week, and then I'll go look at my email. There'll be a lot of cool stuff in there, and then hopefully everybody got something out of this. If you did, leave another comment, whatever, in the comment section. Do what you guys want to do, but hopefully it's all cool, man, and it turned out good for everybody. I had fun doing it, and I'll definitely do it again. And maybe I'll start doing some live testing on this so you guys can see it. Anyway, thank you guys all for showing up, man. I really do appreciate it. Rock on, guys, and have some fun with this thing. God knows I do every time. Thanks, guys.